So today we're going to start working with radicals, and we're specifically focusing on simplifying our radical expressions. Since we are starting the radical unit, we have a lot of vocabulary to cover in this first lesson. So the first word is the square root. Okay, we've heard this before, but what is the definition of square root? Right, so a number has a square root if it is the product of two of the same number. Right, so product meaning multiplication. So a number, it has a square root if we're multiplying two of the same numbers. So for example, 6 times 6 gives us 36. We could say the square root of 36 is 6. So really, if a number has a square root, that means that two numbers multiplied times itself give us that number. So if I were to say, what is the square root of 49, I'm really asking myself, what number times itself gives me 49? And that would be 7. So involving square roots, we now have terms to talk about these square roots. So the radical is what we call that symbol. So this symbol is a radical. That's the symbol. The radicand is the number beneath the symbol. The number beneath the symbol. So, for instance, if I have the square root of 10, this symbol is what we call the radical. My 10 is what I call the radicand. Alright, so moving on to more vocabulary. I also have the nth root. Very similar to the square root, but we just change it a little bit. Right? So a number has an nth root. If it is the product of more than two of the same number. So our square root example was 6 times 6. Our nth root example would be more than 2 sixes. So something like 2 times 2 times 2. 2 times 2 gives me 4. 4 times 2 gives me 8. So if I want to take the root of 8, the square root of 8 would say what number times itself gives me 8. The third root of 8 is going to say what number times itself 3 times gives me 8. Right? And just like square root, we would say, oh, well, the answer is 2, because 2 3 times gives me 8. Right? We say this as third root of 8. Right? So this number tells us what we're going to say. So the nth root, we just say that because it can describe any number. So I can say the third root, the fourth root, the fifth root, the sixth root. We could change that, and that just means how many times we're multiplying the same thing. The index is the little number above the symbol. the little number above the symbol. So something like the 5th root of 100. My index here is 5. It's just that little number. It's the root that we're talking about. And last but not least, we want to know, what does simplest form look like when we're simplifying radicals? And simplest form is a radical with index n, so any index is in simplest form, if the radicand and remember, radicand is the number under the root. If the radicand has no perfect nth powers. And we'll talk more about that when we begin to simplify. But really, we're just saying that if I'm taking the square root, there are no perfect squares left. If I'm taking the third root, there are no perfect third roots left. Same thing with 4th, 5th, however many, depending on what the index is. So let's get into some examples. If we want to simplify our square roots, in example 1, we want to simplify square root of 18. So our key point, the first thing we need to do is find all prime factors. And the best way to do this is to use a factor tree. So a factor tree, we just break each branch from the original number and say what two things multiply to give us 18. Well, I think, all right, starting with 1, 1 and 18, that's not going to help me. 2, 2 and 9, that works. Right? If you are not sure, you just start testing it out in your calculator. 18 divided by 1, 18 divided by 2, 18 divided by 3, and keep going until you get a number that works. Step 2, we want to circle all primes. So once we factor a branch, if I find a prime, I circle it to know that my branch is done. So 2 times 9, 2 is prime, so I circle it and that branch is done. 9 is not prime. I can break that apart because 3 times 3 gives me 9. But 3 is prime, so I circle 3, and this 3 is prime. Once all of my branches have been circled, I know that I have completely factorized the number 18. Step 3, I want to rewrite your prime factors under a root. So I found that 2 times 3 times 3 gives me 18, so I can write that under one root. 2 times 3 times 3. So it's the same thing as saying square root of 18. This is combined and this is broken down. It's easy for us to see once we break it down. Step 4, I want to connect pairs of numbers with a line. Now, the reason we're connecting pairs is because actually a square root is a hidden 2, which means I want to pull out groups of 2. Because we know that our definition of square root meant that we were multiplying two things together. So now we're going backwards. We want to take those two things out. So connect my two things in line. 2 doesn't have anything, so it just stays there by itself. But 3 is a pair with 3. So I connect those with a little loopy line so that I know that those match up together. Step 5, the important part of simplifying. This is also where we make some mistakes, so we need to make sure that we're really being careful with step 5. So for each pair, you pull out one of that number in front of the radical. Right? So what that means is I have a pair of 3s. So I'm going to pull these 3s out of the radical. But for each pair, I'm only pulling out one of that number. So I have 2 3s, but I'm going to pull out just one of them, and then I leave whatever doesn't have a pair inside. So my 2 stays inside. And that is the square root of 18 simplified. All you have to do is break it down in a factor tree, find your pairs, and pull one of each pair out. So let's try another example. Example 2, we want to simplify square root of 80. So here we have our key points again. So first step, we want to find all of our prime factors. So we break it down. The easiest factors that I can think of are 8 and 10. So I have 8 and 10. I want to check, do I need to circle any of these? No, I can keep breaking down 8. 8 is 4 times 2. 2 is prime, and 4 can break down to 2 and 2. So here I have 2 more primes. 10, I need to keep going, so I have 2 times 5, both of which are prime. So I've circled all my primes, I've factored all the way. Step 3, I want to rewrite my prime factors under a square root. So I have 2 times 2 times 2. You need to be crossing them out as you go to make sure that you're not missing any. And then 2 times 5. And those are crossed out as well. Step 4, I want to connect my pairs of number with lines. So we can see that I have a bunch of 2s and 1 5. I do not want to connect everything. All I'm doing is connecting pairs, which are groups of 2. So I'm connecting this pair. Then I look and I see I have another pair. Well, great, I'm going to connect that. And then I don't have anything to connect with the 5, so I just leave it by itself. Step 5, our most important step. For each pair, I want to pull out one of that number. So I have a pair of 2s, so I'm going to pull out a pair of 2s for this group, and I'm going to pull a 1, 2 for this pair as well. So I pull out a 2 for the first pair, a 2 for the second pair, and then my 5 stays inside. And then one extra step which we need to add in this case is, once you've pulled out any pairs, you may need to multiply what's outside and inside. So here I have 2 numbers outside, so I'm going to multiply those together because I pulled 2 things out. I'm going to have a 4. If I had extra things inside, I would also multiply those back together. But in this case, I just have my 5, so my simplified answer is 4 the square root of 5. So now, you should try on your own. Number 3 and number 4, write this in your notes. You can pause the video so that you can try and check your own work following the key points. We'll come back and give you the answers to see how you did. Alright, so you should have gotten for number 3, 3 the square root of 3, and for number 4, 10 the square root of 3. If you didn't get these things, you should go back, check that you factored correctly, Check that you didn't accidentally forget one of the prime factors when you rewrote them underneath the radical. Check that you're pulling out only one number for every pair. And if you still can't find your mistake, put a star next to it, write a note next to it so that we can talk about it when we come back to class. Now we are going to talk about simplifying nth roots. So very similar to solving and simplifying square roots, but now we just have different roots. So instead of pulling out pairs of 2, we're going to have to change that a little bit because our index has changed. So if I want to simplify the 4th root of 80, the first step I'm going to do is just like it was before. I'm going to prime factor using a tree. So I break it down. I know that 80 is 8 times 10. This is 2 times 4. 2 is prime. 4 is 2 times 2. And 10 is 5 and 2. So all of my prime factors. Step 2, just like it was before, was circle your primes. Step 3, rewrite under the radical. So here, this is where we have to remember the 4 has to be in our index. Right? So that's a really common mistake. So quick tip, don't forget to write the index number, right, this 4. We often forget to write that, and that changes the whole problem. So I'm writing the 4th root of, and then rewriting all of my prime factors. 2 times 2 times 2. I got that one, that one, that one, times 5 times 2. That one and that one. Right? So step 4. All right. Look at your index. All right. This is going to tell you how many groups you're looking for. All right. So 5 is connect groups. Connect groups of index number with a line. So with our square root, we said connect pairs. Well here, because we have a 4, my index number is going to tell me I don't want pairs, I want to find groups of 4. So do I have any groups of 4? Well, I have a 2, 1, 2, 3, and I have this 2. So yes, I do have a group of 4. So then, step 6, for each group, and in this case it's a group of 4. If your index is different, it might be a group of 3 or a group of 7. We don't know. It depends on the index. For each group, you pull out 1 of that number in front of the radical. So here I have 1 group of 2, so that means all of these 2's I'm going to pull 1 2 up. Then the only thing I have left, this came out, is my 5. So again, I need to remember writing the 4th root of 5. So same thing, quick tip. We really have to remember when we're writing our final solution, we cannot forget our index. Because if I don't have my index here, that means there were only 2 2's inside instead of 4 2's inside, and that is not the case. So let's try one more example. I want to find the third root of 135. So my first step, I need to prime factor. Well, I don't really know the factors of 135 that well, so I use my calculator. I'll type 135 divided by 2, and I get a decimal, so that's not going to work. Alright, then I can do 135 divided by 3. I get 45. Alright, so I can use that. So 3 and 45, 3 is prime. And now I need to factor 45. Well, I know that 45 can be 9 times 5. 5 is prime. And I can break down 3 to 3 and 3. So now I have all of my branches circled. So I can write all of my prime factors under the root. 3 times 3 times 3 times 5. Once I have them written under the root, I need to look at the index. And I made my own mistake by forgetting to put my index. So I need to look at the index to remind me how many am I looking for? What groups do I want to connect? And I find it the 3, which means I need to find groups of 3. So I look at my numbers. Do I have any groups of 3? Yes, I have 1, 2, 3 threes. So for every group of 3s, I'm going to pull out one number in the front. So I have the 3. Again, I cannot forget my index, the third root of, and my 5 is left inside. And that is simplified. So now you can try it on your own. Again, go back, following the key points, trying not to forget your index in your final answer, and we'll come back and see how you did. Okay, so for number 3, you should have gotten 2, the third root of 5, and 5, the third root of 2. Make sure you're checking that you have your third roots. If you had any mistakes, double check that you factored correctly, you didn't forget any of your prime factors under the roots, and that you were pulling out only 1, 2 for every 3 that you found, and 1, 5 for every 3 that you found under the root. So here we have 3 problems for our self-check. Go ahead and complete these. These are both square roots and nth roots, so make sure you're looking at the right place in your notes for help, and we will go over these in the Do Now when we return to class.